Okay, so today we will start our today finally we will start design patterns. Um, and by now we have covered a lot of topics such as UML and software design principles such as solid and grasp, grasp to, let's say, understand easily design patterns, right? So we covered elements which can lead to design patterns, and we today we will start. Okay, so we can think of design patterns as a typical solutions to common or general problems, right, in software design. And so you can think of each design pattern as a, common way of solving general problems, like a blueprint, right? And you can customize depending on your situation and implement in your code. And we might have a, let's say, question. What is the difference then between design patterns and algorithms? So what do you think, guys? What is the difference between them? Any thoughts?
So can you hear me?
Yes, sure.
So question is, what is the difference between design patterns and algorithms? So I
Yes.
think that algorithms are more concrete way to describe the solving the problem. It's like the steps to solve a certain problem. But design pattern is approach how you how it is better to build this algorithm to solve this problem. So if it
Yes.
was clear.
Yes, yes, this is true. Basically, algorithm is a sequence of steps, right, to solve a particular problem, while design patterns, by the way, design patterns can use algorithm, and also design pattern is kind of more high level approach. Here you can we can define, if we follow design patterns, we can define relationship between elements, right? And the, let's say, problem will also be more general. It will be in a more high level. So these are the basic differences between design patterns and algorithms. So design patterns can be divided into many categories, but let's start with creational design patterns. So creational design patterns uh, provide various ways or mechanisms, right, to create your objects in a more nicely way, which uh, depending on your situation, right? By following these creational design patterns, you can have flexibility and reusable code within your project. So we have 5 design patterns here, starting from factory method, abstract factory, builder, prototype, and singleton. And today we will cover factory method, abstract factory, and builder. Okay, so let's go with factory method. So factory method is a creational design pattern which will create a way of creating objects in superclass, but uh, let's say delegate the concrete implementation into subclass. Okay, so let's see this in some example. For example, let's imagine that you are working on a project, on a system, which you have to automate logistics. Basically, you are working in logistic management application, right? So the first version of your app can only handle, let's say, transportation by trucks. So the main logic with transportation lives inside your track class, right? And everything is good, and you have defined your, let's say, main relationship between your logistics and track in the following way, where your logistics class directly connected to track class, right? And so it works. But at some point, uh, you have a request of supporting ships. So this will be a new feature, and you have to also support ship by overseas. But unfortunately, your current version does not support ships. Why? Because your logistic app is tightly coupled with your track class, right? And so there is no support for ship unless you change a lot of your code, and you have to made a lot of you have to make a lot of changes to the whole application. So instead, what you could do, you could just generalize transportation by introducing transport, right? And you can define further by track or ship class by these subclasses, right? And whenever deliver is required by transport, you can delegate the implementation to the concrete classes such as truck and ship, right? And whenever deliver is delegated to truck, it will deliver by land, or in 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 a ship case, you can deliver by sea, right? So uh, and so you can all this is also a solution by factory method, where where you introduce the level of abstraction for your logistics class. For example, you have to generalize logistics class, and you have to generalize road logistics, right? So, and now logistics class is connected to the transport, right? Here we have a transport class, and the concrete classes, such as road logistics and sea logistics, then they are connected to transport, concrete transport such as truck or ship, right? And the necessary methods can be delegated to sub classes of logistics, right? And they will use the particular class for a transport class. Okay, so now you have a good solution if you follow this factory method, right? Because now your logistic app is connected with transport class, and by doing so, you can now support road logistics by trucks, and sea logistics by ships. You can also extend further. For example, you can also add air logistics, right? By, airplanes and so on. So now you have a extendable solution, a maintainable solution. So if we look at the structure of the abstract, sorry, factory method pattern, here we can see that first of all, we have to create an abstract level for creator object, right? Here we have creator. Then we should define further for concrete creators, such as concrete creator A, concrete creator B, right? And our superclass concrete creator will work with the abstract product, okay? And this product class also, this might be interface in Java case, can be further declared as or extended as concrete product A or concrete product B. And your concrete creators will work with concrete products. So this is the main idea behind factory method. Do you have any questions about this pattern? Okay, I hope everything is clear. You can ask any questions. You can interrupt me if you have questions. So the next pattern is abstract factory. This is also very similar to factory method with some exceptions. In abstract factory, besides creating, let's say, subtypes of products with let's say extendable factories, you can also introduce families of products. Okay, and how? Let's see this an example. Let's imagine that you have to create a shop furniture simulator where you have to, let's say, produce the following furnitures. For example, uh, chair, sofa, coffee table. So these are the family of furnitures, right? For example, here we have family of furnitures, and we also have a style for each of the family. For example, uh, a chair can be can be in a style of Art Deco, Victorian, or modern, right? So by combination of families of products and styles of products, what we have 9 different products, right? How can we automate uh, a management system which can produce such a combination of, let's say, product? We can, if we think what would be the first thought, this would be the first solution, right? So you will just create furniture factory, and you will define separate methods for each of the products. For example, create Victorian chair, will return Victorian chair, or create modern chair, will return modern chair, and so on. So if we have 9 products here we should also have 9 methods, 9 separate methods, right? But we have some problems with this solution. Let's say, uh, let's imagine that some of our one of our clients ordered, let's say, 2 chairs 2 weeks ago or last week, right? So he ordered Victorian chair, but now he is asking for a sofa. He is just asking for a sofa, and uh, when he ordered Victorian chair, he specified the style, right? He needs Victorian style of chairs. But this time he asked for a sofa, and he didn't specify style. But apparently, we should have understood it. But with this solution, we cannot, and we can just return the any type of the chair, since we do not know the style by the request. And we may have some problems because since client is asking for a, let's say, chair or some any furniture, and he had specified the style in his previous request, right? And this time we are asking what is the style, but he uh, I mean, we are asking for a concrete name of the method if we say in a programmatically way, right? But he doesn't know about our structure, and he doesn't care about the name of our factories or about our methods. Here we have conflict. How can we solve this issue? Uh, the right solution could be uh, implementing abstract factory by introducing, first of all, we have to uh, generalize families of products, right? Here we have chair, coffee table, and sofa, right? And pay attention that we are not generalizing them. I mean, we do not have a single furniture superclass for chair, coffee table, and sofa. Instead, we are defining separately chair, coffee table, and sofa, and uh, we are extending further each of these classes. For example, uh, in the case of chair, you can see that we have two subclasses of chair, which is Victorian chair and modern chair, right? And in our abstract, let's say, furniture factory, which is represented by interface on the right diagram, right? We only work with the chair interface, the top level class. And the concrete classes such as Victorian furniture factory or modern furniture factory, we work with concrete style of the furnitures. For example, in the Victorian furniture factory, whenever chair is requested, we return Victorian chair, right? Or whenever coffee table is requested, we return Victorian coffee table, and so on. And the same for modern furniture factory, but this time we will return the furnitures in the modern style. So by doing so, now our client, if we look at the overall structure, um, our client is connected to concrete factory. For example, whenever, let's say, client is connected to, whenever client is asking for some chair, he has to somehow specify the type, right? Whether he needs Victorian or modern or other style. Uh, we have to bond, or we have to connect this client to the concrete class, to the concrete factory, right? But client is working with abstract factory in a general way, right? But whenever he needs some, let's say, I don't know, chair or another furniture, we will ask from the concrete factory depending on the client's preference, right? So this is about abstract factory. So did you understand it? Maybe you have questions about this pattern? Okay, I hope everything is clear. And now, what do you think, guys? What is the difference between abstract factory and factory method? Any thoughts? So, guys, we have Maxim here, right? Maxim Korsunov, are you here?
Yes, I'm here, but just not really sure about the difference.
Okay, so then let me, let's say, let me explain the difference. Okay, if you remember in the factory method, let me back to the structure of the abstract factory method. We have a general type of product, right? So we have one general type of product, which is product interface. And we are now extending further for concrete product A and concrete product B, right? In the abstract factory case, we have several families of products. For example, we have product A and product B, right? And we can also, after that, we have to define further for product A1 or product B1. Let me explain in the real example. For example, here we have chair, coffee table, and sofa, right? So here we do not have a single superclass for these furniture, such as I don't know, maybe we would have furniture class for as a parent class for chair, coffee table, and sofa, right? But in abstract factory, we do not have this. Instead, we have let's say families of products. Even in the abstract factory, we are in the furniture factory, we have different methods. We are treating them as a separate objects, right? Chair, coffee table, and sofa. And in our concrete factories, such as Victorian or modern, we are working with concrete, let's say, uh, with the concrete uh, child class of of a chair or coffee table, right? For example, in Victorian furniture, we are working with Victorian chair. So the difference is we have several, let's say, group of objects or families of objects, family of objects here in our abstract factory, such as chair, coffee table, and sofa. But in factoring method case, we would have only one general class, one parent class for them. So this was about the difference about abstract factory and factoring method. And now let me talk about builder. So builder is about the way of creating complex objects in a more structured way. So we will do that by step, basically. So you may have a different types and representations of an object using the same construction code. Okay, how? Let's let's look at this by example. For example, you have a task where you have to create a house with the possibilities of several features, right? For example, a single house can be in the types of house with garage or house with swimming pool or house with fancy statues or house with garden, right? We have to, let's say, implement this. We have to solve the, let's say, problem of creating different combinations of a single house. How we can implement it? The first way, you can just extend, you can just declare a abstract class house, right? And you can extend as a children classes such as house with garage, right? House with swimming pool or house with fancy statues and so on. You will have a child classes which will, let's say, implement different properties for the house, right? But the problem with the solution is that you may end up with infinitive number of child classes, since we have a lot of combinations. For example, even with these displayed elements, we can create a lot of combinations, such as we can create a house with garage and swimming pool, right? Or we can create a house with swimming pool and garden. You see, here we have a lot of combinations, and inheritance is not a very good option here. The next simplest solution could be you can just declare a constructor which can accept the properties, right? For example, whether the house should have let's say garage or swimming pool or statues or garden, the number of windows, the number of doors, and the number of other elements and so on, right? By doing so, we can just create a create a house which can combine a lot of properties. But if you look at the usage code samples, right, on the uh, on the diagram, we can see that this is not a very good solution, since we have to also say and then say the things that we do not need. For example, on the left part, we have just a house with garage, right? And we do not need swimming pool, statue, or garden. Here, we should also specify and say explicitly that we do not need swimming pool or statues or garden by passing, let's say, null or false variables here, right? So this is not the very effective way, and the correct and the more effective way could be the builders, by implementing builders pattern. What does it say? Builder pattern suggests that you have to extract the object construction code out of its own class and move it to a separate object called builders. For example, here we have house builder, right? And in this house builder, we can create methods for each of the property, and the client will call the methods, will call only the method which are in interest of him, right? For example, if he needs, let's say, a house with garage only, I mean, if he doesn't, okay, let's imagine that he doesn't need a garage. He can just call the methods of build walls, doors, windows, and roofs, and he can skip calling build garage, right? So by doing so, uh, letting the client to be aware of only on the things that he needs, right? And now he doesn't call unnecessary things. So by doing so, we can also have other types of builder. For example, let's imagine that we have a different types of houses, such as wooden house or iron houses, and probably the elements should all will also depend on the let's say type of the material, right, that we will use for our house. So we can have wooden house builder or iron house builder, and we will specify the we can declare the methods separately for these builders. So this was about builder class. So do you have any questions about this builder pattern? Okay, I hope everything is clear. And now let's practice and let's solve some problems using the patterns that we covered. For example, the first problem is before we start, this is also an individual task where you have to work by yourself. So you have to apply a let's say this a pattern on the problem given, right? And you have to draw a UML diagram of your solution. So the first problem. So imagine that you are working on a door factory software system where you have to represent each element by software entities that are classes, right? So you have a door entity whose type might be an iron door or wooden door. You have employees who can work on either wooden doors or iron doors. And finally, you have factory types which might produce wooden doors and iron doors. So your task is to apply abstract factoring method and draw a UML diagram. So you have about 15 minutes to finish this task. I mean, if you finish earlier, you can let me know and we will discuss your diagram. But after 15 minutes, I can ask, I may ask from any of you, okay? So if you have no questions, you can start. So not to disturb you, I will just turn off my mic and my camera. I hope that the time was enough to do some work. So, is anyone ready?
I think I'm ready.
Yeah, please share your screen.
Okay, 1 second. So here it is, just a small abstract factory with the, I think this is the wrong name, like door factory here. So this is the main abstract interface, which can produce either iron door or wooden door, and the wooden door factory and iron door factory extends out of it. So as they are real factories, I think, oh, this should not be interface. Yeah, this is a mistake, I think. And well, and as it's set in the task, they have its own employees that like special for wooden and special for iron. So therefore, I put some attributes here, like employees, and they can also produce iron and wooden doors, both of them.
So this is abstract factory, right?
Yes.
Okay. So the first, let's say, okay, why don't you generalize your door in door factory?
Uh,
I think it would be better, right?
well, it's just, I think, is it a pattern of abstract factory?
Yes. So the point here is to uh, and have a combination of door concrete types with employee concrete types, right? You have a, let's say we can think of wooden employee and iron employee, and we have also have employee abstract class. Then we have a door, let's say abstract class and concrete classes such as iron door and wooden door.
Mm-hmm.
And employee overall works with door, and the concrete employee such as wooden employee produces with wooden door, and iron employee produces iron door. And in each factory, we have, let's say, uh, so door factory should have two methods probably. For example, get employee or provide employee, right? Which will uh,
Okay.
produce uh, parent employee and produce door. And for your concrete factories, you will implement them in a let's say in a more concrete way, such as whenever provide employee is requested, you have to provide, let's say, concrete concrete employee, right? For example, iron employee, and whenever produce door is requested, you have to produce iron door.
Yeah, I understand now. Thank you.
You're welcome. Okay, so you will complete, but anyway, I will note you. So
Okay.
Maxim, thank you for your solution. So anyone? Is anybody ready to present his or her work? Okay. So let me then ask from Alina. Alina, are you here?
Do you mean me?
Alina, sorry. I think you are the only one who is online. So Alina Bagdanovi, yes.
Yes, 1 second.
How's your work? Okay, so you're okay, Alina.
Oh, 1 second.
Ah, okay.
Do you see the screen?
Yes.
Okay. So what have I got here? I have a client who is calling abstract factory, which is like the thing which is creating some kind of door. It's not known which. It would be specified by the client, which implementation will be used. So, and iron door is producing iron door factory produce iron door, which implements the door interface, and the door interface is required to be returned to the client. Something like this.
You see, so you have a abstraction for factory, right, as door factory, and for
Yes.
doors.
Yes.
Okay,
I
so
haven't put the employees as it was done by Matvey, but
and this is a factory method, right?
isn't it abstract factory?
No, this is factory method. But anyway, you have correctly implemented factory method. In order to make this abstract factory, we should have other types of door, right? I mean, other families of door, maybe.
Oh yes, yes. To be added to both interfaces. Yes.
Yes. So
There is only one product. That's why it's not visible here.
But anyway, this is a correct implementation of factory method. Okay, thank you, Alina, for your solution. I will also note you. Okay, so anyone else? We have Anna here, right? Anna.
Yes.
So how are you?
Okay.
How was your work?
I tried to open it. You can see, yes?
Yes, we can see.
So I have the factory interface. I should add there also one method. You can has an employee and produce the door. Employee could be iron employee or wooden employee, and the door also. And I have three interfaces for them.
So I see. So you have employee, you have door. Okay. Okay, so employee, the factory, your abstract factory is connected to employee, right? Yes, and your factory is, yes, there should be an arrow to.
They are connected. Maybe employee is created. The object of employee is created inside the factory. Should be, I think.
Employee should be created in the
factory.
Yeah, concrete factory. Yes, yes. You're correct. Yes. This is a good structure of. What do you think? Is this a factory method or abstract factory?
Abstract factory. I think yes, abstract.
Well, but I think this is factory method.
Why? We have iron door and wooden door, and it's a family. Okay, we have only doors, and it's not a family. If we will have, for example, something else, it will be a family.
Yes, if you have connected employee and door somehow in another way, it would be abstract factory. But anyway, you have correctly implemented factory method, and I see that you have correctly understood factory method. I mean, thank you for your solution. I have also noted your active participation.
Thank you.
You're welcome. So, anyone else, guys? We have Big Jan Talgat here, right? Okay, Big Jan, are you having some troubles with connecting your microphone? Okay, then let's ask from someone else until Big John fixes his microphone. Okay, so Idel, are you here, Idel? Can you talk to us? What about Kirill? Kirill Fidosov.
Yes, I'm here.
Okay, so how was your work?
I can show, but I think it's similar to the Alina's work, I guess. Let me share.
Oh, that's fine. That's fine.
Do you see the screen?
Yes, we see.
Yeah, so the same. I thought that we have just only one type of product, so I don't know how to put the abstract factory here. So I just have a interface door factory and then two implementations which have the same method. And I just created a separate interface for door and a separate interface for employee. And I just connected the employee to the factory by some method in the employee, which returns the concrete implementation of the factory where he works, basically, something like that.
Okay, so employee is so door factory will also have connection to employee, right? I mean, there is a
So in my employee has the connection to the factory.
Yes, employee is using door factory. Okay, so okay. I think this is it should be abstract factory. Why? Because you are connecting two abstract levels such as door factory and employee, and you are getting the concrete type of door, for example, iron door or wooden door, by the type of factory, right? I mean, you are getting the iron door employee.
Yes.
So this should be abstract factory, I think, yes. Or we can also consider. I think this is more like factory method. Yes, because your employee is playing a role like client. I mean, he's just getting.
Yeah, kind of.
Yes. Okay, thank you, Kirill, for your solution. I have also noted. Okay, so Ideal was connecting, right? Can you connect this time? If you have some problems with your mic, you can just send the link to your diagram to the chat, and we will discuss. I will share my screen, and we will see. Okay, what about Big John? Big John, could you connect again? Okay. So what about other problems, guys? I mean, the problem, the number 2 and problem number 3. So you can also start working even if you have, let's say, participated. I mean, even if you earned some points, you can also earn. I mean, if you show your work again. Okay, so I will be waiting for you for other, let's say, solutions. So, is anyone ready? Okay, so our lab is also almost over. If you have, um, if you want to show something, if you want to present your work, I will be there. Otherwise, I thank you for your participation, and our lab is over.